So we'll start by setting it equal to 0. Step 2 is to factor. Do I need to factor this? Isn't this already factor? Aren't those factors, right? So do I need to factor this? They already did it for us, so that's convenient. Factoring is done, so I don't need to factor. So then for step 3, once we have those factors, what do we do with those factors? Set them equal to 0 and solve, right? So we need to set all the factors equal to 0. Some people might say, do I need to set the 5 equal to 0? Well, if you're unsure, let's do it. Does that make any sense? 5 equals 0. Is that ever a thing? Is that ever possible? No, right? So we don't need to worry about the 5, but if you want to write it down just to make sure, you can do that. What's our next factor here? X minus 2. So we need to set that equal to 0. It says cubed. Do I need to do this 3 times? Do I need to set x minus 2 equal to 0 3 times? No, because what's the answer going to be every single time? X equals 2, right? So you don't need to do it 3 times, right? You know that that's going to be x equals 2. You don't need to see that it's 2 3 times. And then we'll do x plus 1 equals 0. And we'll get x equals negative 1. So today we're going to start writing our zeros like we did yesterday. So our zeros, or our solutions, or our x-intercepts are 2, 0 and negative 1, 0. So when you solve and find the solutions, you are also finding the zeros or the x-intercepts, right? So what does that mean? That means when you graph this polynomial, it's going to look like probably like wavy and stuff like that, but it's going to touch the x-axis at both of these places, at 2 and at negative 1, right? This one's interesting though, because we just said, do we need to do this 3 times? Well, no, we don't need to, because we know the answer will be 2, but the answer will be 2 3 times, right? And that doesn't mean it's going to touch the x-axis in 3 different places, right? Because it's always at 2, right? And that's exactly what multiplicity is. This guy here has a multiplicity of 3. And what that means is the way that it touches the x-axis at 2 will look different than the way that it touches the x-axis at negative 1. This one only has a multiplicity of 1 because it only happens 1 time. Okay, so that's what we're starting to talk about today. So let's do another review problem. This one, start by setting it equal to 0. Again, this is just reviewing what we did yesterday. What kind of factoring will I have to use on this one? Grouping, there's 4 terms. So draw your line down the middle, and I want you to do this factoring. Do this on your own. Factor this by grouping. Factor out the greatest common factor on the left and the greatest common factor on the right. All right, on the left, you should have factored out an x squared, and that'll leave you with x minus 2. On the right, the common factor is 9, but you want to pull that negative out with it, so that will leave you with x minus 2. So that's good because those match. So one factor will be x minus 2. And then what will be the other factor? X squared minus 9. What's left? You have two options here. You can continue factoring because the x squared minus 9 will factor into x minus 3x plus 3, and then you can set them equal to 0, or you can start right now setting them equal to 0. So why don't you do that right now? Why don't you, so we did 1, we set it equal to 0, 2, we factored. Now you're going to set those factors equal to 0. So set those factors equal to 0 and solve. As long as you don't forget your plus or minus, you should get x equals 2 and x equals plus or minus 3. So we have 3 zeros here, 2, 0, 3, 0, and negative 3, 0. Again, these are the zeros. They're also the x-intercepts. So this function will touch the x-axis at 2, 3, and negative 3, right? So it has 3 zeros. It touches the x-axis 3 times. These are also the solutions, okay? So again, we just practiced what we've done yesterday. That's all we just did right now. We were just finding the zeros, practicing what we did yesterday. Today, what we're going to add to that is just this multiplicity part, okay? So the multiplicity is how many times that 0 happens, right? Like above that 0 happened 3 times, so that has a multiplicity of 2. But that also tells us how the graph touches the x-axis. And next week, you're going to have to start graphing these polynomials yourself on Monday, so you need to know what it looks like when it touches the x-axis. So when a factor is raised to an odd power greater than 1, so when the multiplicity is an odd power bigger than 1, so this would be an example of that right here. This one up here, 2 had a multiplicity of 3, so that's an odd power greater than 1. Then at that x-intercept, the graph is going to do a cubic-shaped wiggle when it touches the x-axis. It's going to go straight through it. So if you have this was at a 0, our 0 was at 2, 0. So if that's at 2 for this guy right here, because the multiplicity was 3, and that's an odd power greater than 1, then when the graph goes through the x-axis, it's going to do a little cubic-shaped wiggle as it passes through the x-axis. And we say cubic-shaped wiggle because this is what the x-cubed graph looks like, the parent function. If the multiplicity or the power of that factor is just 1, it's going to cross through the x-axis at that point. So for example here, this one only had a multiplicity of 1 because it only happened once. Its factor only happened once. So at that point, at that 2, 0, 3, 0, at all of those, it's just going to cross straight through. It's not going to do any wiggling. It's just going to cross straight through. If the multiplicity is 1, so if the power of the factor is 1. And then if the power of the factor or the multiplicity is even, then the graph is not going to go through the x-axis. It's just going to touch it, and it's going to bounce off, okay? So if that power is even, and you have an x-intercept there, it's not going to go through. It's going to just touch it and bounce off. So it will still touch the x-axis, but it won't go through it if the power is even or if the multiplicity is even. So for example, this factor here, what 0 would that give me? X plus 2. If you set that equal to 0, what 0 will you get? Will it be 2, 0? Will it cross the x-axis at 2? If you set this equal to 0 and solve, what are you going to get? 2 or negative 2? Negative 2, right? So this guy, if this is your factor, right, that means the 0 will be negative 2, 0, right? So it will touch the x-axis at negative 2, 0. What's the multiplicity of this factor? 6, right? Because it happened 6 times. That's what that number means. That's the multiplicity. So since that's an even number, you know that it's going to bounce, right? It's not going to go through. It's just going to touch at negative 2 and bounce off, okay? This guy, x minus 3, set that equal to 0, and you're going to get 3, right? So this will have, it will touch the x-axis at 3, 0. But since the power is odd, the multiplicity is 7, then it will do a cubic wiggle, right? It's going to wiggle through. It'll cross the x-axis at 3, 0, and it'll wiggle through. So we're going to fill out these tables for a couple of examples. So for problem number 3 here, how many factors do I have? They've already factored it for us. How many factors do I have? 3 factors. So put 1 in each of these parts of the factors column. So x plus 3, x minus 8, and x plus 4. Those are our 4 factors. For x plus 3, if I want to know what the 0 is, that would be setting it equal to 0. If you take x plus 3 and set it equal to 0, what 0 will you get? Negative 3, right? So the 0 will be negative 3, 0. What's the multiplicity of that factor? How many times does that factor happen? Just once, so the multiplicity is 1. So because the multiplicity is 1, what did we say it will do there? Cross, bounce, or wiggle? It'll cross. It'll just cross. So I want you to fill in the other ones. Find the 0 for this factor, the multiplicity, and decide if it will cross, bounce, or wiggle. So for x minus 8, if you set that equal to 0, you'll get x equals 8. So this will be a 0 at 8, 0. Multiplicity of 1, so it will also cross. It only happens 1 time. That factor only happens 1 time. Set x plus 4 equal to 0, and you get x equals negative 4. So that'll be negative 4, 0. That will happen 1 time and cross. Go ahead and fill out the number 4 table on your own as well. You have 3 factors again. So find the 0, the multiplicity, and decide if it will cross, bounce, or wiggle. Yeah, the factor itself is just x plus 5, right? The 2 just says how many times that happens. So that's your multiplicity. So for the first one, when you set x plus 5 equal to 0, you'll get negative 5, 0. What's the multiplicity of this factor? How many times does this one appear? Twice, right? The power of 2, that tells you how many times it's happening. So that's the multiplicity. When it's an even power, what does it do? Cross, bounce, or wiggle, since that number is even. That's going to bounce. Then we're going to have 5, 0. That has a multiplicity of 1, so that will just cross. Anytime it's 1, it's just cross. And then 1, 0 has a multiplicity of 3, so that's an odd power bigger than 1, so that will wiggle. So make sure you had those written down correctly. And now we'll go try doing it all together with some of the past stuff that we've done. Any questions about cross, bounce, wiggle? Pretty easy. Nothing too crazy. This is where it's going to get a little harder because you're going to have to do a lot all at one time. And next week when we come back on Monday, we're going to be doing all of this for each problem so that we can graph them. Okay, so flip your page over and let's look at number 5. If you don't do it, I'm going to make you do it on your own. I don't think you want to do it on your own yet. Turn it over. Let's do page 5. Problem number 5. So you're going to find all the zeros. You're going to decide the multiplicity, and if it cross bounces wiggles, we're also going to find the y-intercept, which it's been a minute since we've done that, so I'll go over that. And then you're going to have to do end behavior again, okay? And all this is what we need to know to be able to graph these. So we want to make sure we're pros at this by the time we get to Monday. So 1, do I need to factor problem number 5? Do I need to do any factoring? They already factored it for us, right? So now you're going to take each factor and set it equal to 0. You have 4 factors here. These are your 4 factors. So you're going to take each factor and set it equal to 0. The first factor you'll set equal to 0 will just be x. You're not going to set x squared equal to 0 because the factor is just x. That's just happening twice. That's what the square is. That means it has a multiplicity of 2, right? So the factor is just x. It's just happening twice. Oh, yeah, you guys don't have the x minus 5 on the end. Add the x minus 5 onto the end. See this guy? You guys don't have this on the end. Sorry. Add that part on. I forgot to change it. Then you're going to set x minus 2 equal to 0, x plus 1 equal to 0, and x minus 5 equal to 0. So our zeros will be 0, 0. From this, we'll get x equals 2, and that'll be 2, 0. From this, we'll get x equals negative 1, and that will be negative 1, 0. And this one will be 5, 0. So go ahead and put each of those zeros in these blanks, and then decide the multiplicity, and then circle, cross, bounce, or wiggle. So put each of the zeros in the 4 blanks, decide the multiplicity, and circle, cross, bounce, or wiggle. All right, x equals 0, 0, 0 came from this one, x squared. So what's the multiplicity for this one? 2. 2, right? It came from x squared. The factor was x, and it was being squared. So that happened twice. So that's multiplicity of 2, so that will bounce. X minus 2, also factor had a multiplicity of 2. Negative 1 was 1, and 5, 0 was 3. So then we'll have bounce again, cross, and wiggle. So check to make sure you have those correct. Any questions? All right, we're going to skip the y-intercept, and we'll come back to that last, because that's been the thing we haven't done the most recently. Okay, but you've done end behavior just this week. So we're going to do the degree and the leading coefficient and the end behavior. But I want you to look at 6 and 7. Look at 6 and 7. Problem number 6, what's the degree of this one? What's the degree of problem number 6? 4, what's leading coefficient? 1, right? The number in front of that. What's the degree here? 2 is the highest. 3, and what's the leading coefficient here? 1. But what about ours? Is that quite as obvious to figure out what the degree is? It's 8. Why? This is not written in standard form. Does this look like this problem? No, because they've already factored it for you, right? They're already in step 2 of the factoring. So to see what the degree is, if you want to think about it in standard form, you have to think about what will be the highest power of x I would get if I multiplied this back out, right? So you need to look at each section when it's in this form and figure out what will be the highest power of x you'll get from each one. So we need to look at what the first term would be. So here, from this factor right here, what will be the highest power of x we'll get? That would be x squared, right? What will be the highest power of x from this power that we would get? Right here. We get an x cubed out of this one. What will be the highest power of x if you multiplied that out? What's happening? Is it being raised to the 4th power? Is it being raised to the 5th power? It's the 2nd power. So what's the highest power of x you'll get if you multiply that out? X squared, right? What's the highest power of x you'll get from this one? Is that being raised to a power at all? No, so that'll just be an x. And what's the highest power of x we'll get from this last one, though? Cube, right? So all of those together will be 8. And your leading coefficient will just be the number in the very, very front if there's no other numbers in front of anything else. So it will just be an invisible 1. So what is the degree of this one? 8. And the leading coefficient is 1. Okay? So when it's not in standard form, you have to be a little more careful. The degree should always match all your multiplicities together as well if you've done it correctly. So if you add up all your multiplicities here, right, that's going to be the same as the degree, okay? Because you're looking at, when it's already factored like that, you have to look at what the highest power would be if you multiplied it out. So is that degree even or odd? Even, positive or negative leading coefficient? We just said the leading coefficient was 1. I hope you know that's a positive number. So then draw your arrows. What will the end behavior look like if it's even and positive leading coefficient? Right here in this little space, draw your arrows. They both be up, down, like this. Even means together, right? And because it's positive, which way will they both go? Up. So this says we're going to the right. As x goes to the right, to positive infinity, it will go up. And as x goes to the left, to negative infinity, the function will also go up. Okay, so that's just bringing back what we did earlier this week. Any questions about the end behavior? All right, so the last thing we need to go over that it's been a hot minute since we've done it is the y-intercept. And I promise on Monday, y'all are going to be like, Miss Castillo, how do I find the y-intercept again? I don't know how to do that. That's so hard. It's not hard. The y-intercept is always on the y-axis, so it's always when x is 0. And all you got to do is plug in x equals 0 into your original function and see what number you get. That's it. Just plug in 0 into your original function and see what you get. So we'll do 0 squared times 0 minus 2 squared times 0 plus 1 times 0 minus 5 cubed. So 0 squared will be 0. 0 minus 2 will be negative 2. Squared will be 4. So we'll do 0 times 4. 0 plus 1 is 1. So that'll be times 1. And then 0 minus 5 is negative 5. Cube that, and I think you'll get negative 125. And you'll have to multiply all of those numbers together. Because when you have factors sitting next to each other like that, that means they're being multiplied. But what's 0 times 4 times 1 times negative 125 going to be? Do you need to get your calculator for that? Because what happens when you multiply anything by 0? It's 0. So what is this going to be? 0. So your y-intercept here is at 0, 0. Because when you plug in 0 for x, you get 0 for y. That's all you got to do for y-intercept is plug in 0 for x. So none of this stuff that we're doing right now is new. We've done all of this before, right? We're just putting it all together. Any questions on what we did on this one? We're going to do one more together, and then you're going to do one on your own. Questions? Okay, so the last one we did not have to factor. Do we have to factor this one? Is this one factored for us? No. We gotta factor this. But y'all are pros at this, right? You just took a quiz on it yesterday. How do I factor this one? Don't be scared of the x to the 4th. That doesn't really change much. What are you gonna do? There's 3 terms. What do you do when there's 3 terms? 2 numbers then multiply together to get what? Negative 45 and add together to get 4. So do that part on your own. 2 numbers that multiply together to get negative 45, add together to get 4, and then go ahead and do your factoring. I'll give you a minute to figure out those numbers. Should be 9 and negative 5, but be careful here. When I go to put it in factors, can I put x's there? Can this just be x and x? When you multiply x times x, what do you get? X squared. Is that what this is? So what do those have to be instead of just an x? X squared. So now set your factors equal to 0 and solve. I want you to do this part on your own. Set your factors equal to 0 and solve. So I want you to solve those equations yourselves. And I would wait to write the zeros in. To the little table. Go ahead and compare what you got for when you solve those equations with the people nearby. What'd you get when you solved those equations? Did anyone get plus or minus radical 5 as one of their answers? Plus or minus radical 5? If you got plus or minus 5, don't forget you have to do the radical sign. So square rooting both sides over here, you'll get x equals plus or minus radical 5. That's not a nice number, so you need to leave it. For this one, when you square root both sides, should you get x equals plus or minus 3? Not plus or minus 3. 3i, right? Because there's a negative under that radical. So plus or minus 3i. Because it's not 9, it's negative 9, right? You got that negative underneath, it's going to be an imaginary number. So this is kind of interesting, okay? Because this one, you'll definitely have a 0 from each one of those. One of your zeros will be radical 5, 0, and the other one will be negative radical 5. Multiplicity, those only happen once. So multiplicity is 1. So cross, bounce, or wiggle. When the multiplicity is 1. Cross. Are these zeros? 3i and negative 3i? Can I write those as x-intercepts? If I ask you to go graph 3i comma 0 on a graph, are you going to know what to do? No. Where's the I go on a graph? It doesn't go anywhere on a graph. It's an imaginary number, right? So these are solutions, right? But these are not zeros. So these are solutions, but not zeros or not x-intercepts. We've had that happen before. They're imaginary. You can't cross the x-axis at 3i. We don't know where 3i is on the x-axis. So you don't need these last two spots. So this is why sometimes, even though our degree is 4, and we have 4 answers, when you look at your graph, you may not have 4 x-intercepts, right? It may only touch the x-axis twice, okay? All right, for the y-intercept, how do we find the y-intercept again? Plug in 0 for x. This one's pretty easy, so go ahead and do that on your own. Plug in 0 for x and see what you get. If you need a calculator, grab a calculator. You're plugging into the original equation. So plug 0 into x into your original equation.
I don't even know if there is a way to do when. Oh, just.
Nope.
Oh.
Just that one.
Okay. Okay.
So you should be doing 0 to the 4th plus 4 times 0 squared minus 45. Plug it into the original equation. So you should get negative 45. So that should be 0, negative 45. Because this will be 0 plus 0 minus 45. And then we already talked about the degree on this one. This one's nice and easy because it's in standard form. I don't have to think too hard about this one. What's the degree? What's the highest power? Just 4, right? This is in standard form. Leading coefficient is 1, so go ahead and do the end behavior. Do the end behavior on your own. Draw your arrows and describe the end behavior on your own. So the degree is even. Leading coefficient is positive, so that means they're both going to go up, right? Even and positive, both together. Positive means up. So as we go to the right, we're going to go up. And as we go to the left, we're going to go up. Any questions on that?
Can I use this?
Yeah.
So when the degree goes down,
Degrees odd, they're going to go opposite ways, right?
so it'll go
So
down.
it'll go, because you've got a positive leading coefficient, it'll go down first.
Yeah.
All right, so if I didn't get a chance to check your answers, here are the final answers.